So, please remember, you already know these. You've been using them forever. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Yes? Right? Easy peasy. Yeah. Okay. Now, without doing anything further, I want to remind you of something. Oops, I drew that badly. There's theta, yes? Okay, what is opposite to theta? The vertical one, the horizontal one, or the diagonal one? The vertical one. That is opposite. Agreed? Oh, what's adjacent? Everyone's cool with this, right? Horizontal is like the horizon. Okay. Where's the hypotenuse? It's the opposite the 90 degrees. So in this case, it's the diagonal one, yes? Everyone is good, yeah? Now, what would happen if I turn that triangle somewhere else?
It's the same.
It is still the same thing. This is still adjacent, this is still opposite, and this is still the hypotenuse, yes? What if I flip it upside down? Still the same. This is still my adjacent, this is still my opposite, this is still my hypotenuse, yes? No matter what I do with it, the O, the A, and the H are the same, yes? Now in the 9th grade, for some of you, in the 10th grade, for all of you, unless you're from another country, so in grade 4 when you did this, the triangle doesn't matter where it spins or moves, yes? It is always the same. Everybody cool? Okay. So now, let us go to this construction. What is that? That is the X and Y. That's the coordinate grid, yes? Everybody understands that. Agreed? Now, I'm going to check something here. I want to make sure everybody is comfortable working with the coordinate grid. Everybody put a single point somewhere in the first quadrant. If you can't remember what that stuff is, don't put a dot in your paper right now. Just wait a second. I'll wait for everybody to put a dot. That should have been enough time. You should have a dot somewhere out here. What was that? You're a funny kid, man. So, this is quadrant 1. In quadrant 1, every x value is what? Greater than 0, positive. What is every y value? Greater than 0. That is where we usually work with trig, right? Because when we have done trig in the past, we have always been doing real-life measurements, yes? And those real-life measurements must be positive, right? Because that's how you measure. Everybody cool? Okay. So now connect that dot to the origin. I'll wait a second, give everybody a try. You remember where the origin is? Right there. Right? Now, you people are younger than me. You don't have these shaky old man hands. Your line is perfectly straight. Yeah? Pardon me? I know what you're making fun of. Now, stop for a moment. Stop for a moment. I don't have a triangle, do I? Unless I do this. Now, what do I have right there? I have a right angle triangle with which I can do trigonometry. Agreed? And we are going to call this theta. Everybody cool? Which makes this what? Opposite. And this what? Adjacent. Oops. Let's put the O's and the A's inside. Everybody cool? Everybody good? Now, what do we know about this distance? It's the y value. Agreed? Keep that in your head. We're going to come back to it for the next few days. What do we know about this distance? It's the x value. Since I'm in quadrant 1, what do I know about both x and y? They're positive distance. Everybody cool? Okay. Now, I'm going to use a different color. You don't have to, obviously. I'm going to put a dot in quadrant 2 at the relative same position. Everybody with me? So I'm going to go straight across here. I'm going to put it right there. And then I'm going to draw it in. There is my new theta. Is this still adjacent? Is this still opposite? What do I know about those opposite and adjacent values now? Right, in quadrant 2, x is less than 0, or negative. And y is greater than 0, or positive. Everybody cool? Now, I think you know what is happening now. We are going to put one in the third quadrant, at again, relatively the same position. Theta, this is still A, this is now O. What do I know about the third quadrant? X and Y are both less than 0. And lastly, in the fourth quadrant. But you will notice that the O and the A did not change, did they? In the fourth quadrant, X is greater than 0 and Y is less than 0. Is everybody cool with this so far? Most of you, well, not most of you, maybe most of you have seen it. I can't be sure. Trig is a weird one. It gets taught all over the place. I love it, so I teach a lot of it every chance I get. Okay, now this has a lot of vocab here. All right? I didn't want you to have to write it all out because you guys tend to get hung up on writing it out and not hearing what the actual words mean. So I've written it all for you. Maybe you want to underline, maybe you want to highlight, maybe you just want to listen. I'm going to highlight the words I am going to be using over the next couple of days, words that you need to understand. Everybody cool? All right. First thing, an angle is in standard position. That's a phrase you need to know. We've already talked about standard form and things like that. It just is a name given to it. If an angle is in standard position, this is what happens. Its vertex is at the origin. What's the vertex of an angle? It's the corner. Just like the vertex of a parabola is where it turns back on itself. So, if your vertex is right here at 0, 0, that's one condition that it must be met. And the second condition is its initial ray is on the positive x-axis. Now, this is a little strange. I'm going to draw another coordinate grid over here. The positive x-axis is where? Only here. Right? So, is this red angle in standard position? No, because it starts not on the positive x-axis. It starts on the negative x-axis. Everybody understand? So which of those three angles is the only one right now in standard position? Purple theta, red theta, green theta, or blue theta? Just purple. That is the only one in standard position because it starts on the x-axis positive and it has its corner at 0, 0. Is everybody cool? Everyone is good? Okay. So the initial ray is where we start from. Now the next word that you need to know, the other ray, so the other side, is the terminal arm. I want to highlight that in green because the arms go together. So, this is initial, this is terminal. Everybody cool? For purple theta. Is everybody good? Now look at red theta. Red theta, its initial arm is where? It's the negative x-axis, yes? We would agree that this is how that red theta has been measured, yes? Okay. But, that's not how we measure angles. We measure angles, like we measure everything else, from a single starting point. And that starting point is here, the positive x-axis. So, if I go counterclockwise, which way is counterclockwise from this line? Is it up or is it down? Up. If I go up from the x-axis, counterclockwise, I have a positive angle. So this right here in purple is a positive angle. What is the maximum amount it can be? 90. Because when I get to here, I've now gone past. Everybody understand? So if I were to keep in standard position and I were to go out to red theta, then I would have to go this far. Do we understand that? So red theta is actually greater than 90, even though it shows up over here for the way we would do trig. Does everybody follow what I said there? The real measure of the angle starts here and goes to here. Where would green theta go? Start here and go all the way around to here. And the blue theta would start here and go all the way around to here. Is everybody good? If they're in standard position. Everybody cool? Now, of course, we can't do trig on red theta in standard position, can we? Because its angle is bigger than 90. Most of you, if you've only done grade 10 in Canada, haven't done trig with an angle greater than 90. So that is why we have to be aware that there's the other side of the terminal arm that does make a 90 degree. Is everybody cool? Okay, let's see. We're going to do the first one of these together. You're going to do the rest, and then I'm going to put two more on here that I want you to do, okay? So, it's 30 degrees, and it needs to be in standard position. If I'm starting in standard position, where does the first line go? Positive x-axis. And 30. Is that a positive number? So do I go counterclockwise or clockwise? Counterclockwise, so I go up, and I got to go up 30. Well, if I get all the way to here, it's 90. What's halfway?
45.
And not 45. I've got to be a little less than 45. So we're just sketching, so we're going to put it out there. Does everybody understand what I would like you to do here? Great. You try the next 5. Meanwhile, I'm going to put up 2 more here that I want you to do. Oh, by the way, 3 presents under my tree had no tags or cards. If you were one of the people that did that, thank you very much for my present. Yeah. Because it was you, Gervier. Huh? I didn't see an empty box. No.
People call like Die Hard a Christmas movie because it takes like all these Hallmark.
No, you're totally wrong. Die Hard is totally a Christmas movie.
And Paul Blart isn't.
A, it takes place at Christmas.
So does Paul Blart.
B, the moral of the story in Die Hard is that John McClane will do anything to be with his family at Christmas time.
Yeah, just like Paul Blart will do anything for takes a holiday. Yeah. Paul Blart will do anything for his mom.
All right, where is B? Second one, out there. Where's C? Third one, down there. Where's D? First one. Where's E? Fourth one. Where's F? Second one. And they all go this way. Right? Okay. Where's G going to go?
It's going to go the other way.
It's going to be down there. It's going to be in quadrant 4. Right? That is negative 50. What else is it? What would it be if I had gone this way? 310. Where's this guy going to be? Starts there. In the third quadrant. How far is this? Negative 110. How far is this? 250. Is everybody cool with working with and around this point? Everyone is good? Okay. Turn the page over. Page 192. Reference angles, new word. If you have an angle in standard position, of which we have done all of these, yes? The reference angle is the angle between the terminal arm and the nearest x-axis. And please highlight nearest x-axis. Now, the reason the reference angle is important, I've already talked about it, but I haven't actually shown you it. The reference angle is important because once we are past the first quadrant, the reference angle allows us to do trig. Why is it only when we're past the first quadrant? When we're in the first quadrant, we're under 90 degrees and it's okay. Everybody cool? So, everybody draw me a standard position angle in the first quadrant here. Doesn't matter what it looks like. Where is theta? Right there. Right? That's the angle. What's the reference angle? The reference angle I will do in light green because I highlighted it in green. It's from the closest x-axis, so it's right there, yes? So you will notice in quadrant 1, theta is the reference angle. Everybody cool? All right. Now give me one out in quadrant 2. Where is theta? Well, wait. I'm going to do this. I'm going to give a pink dot and a green dot. Where's theta? Pink dot. Theta is here. Where's the reference angle? There. because that is where we make our 90 and we can do trig. Everybody cool? All right, let's do the third quadrant. Down there. Where's theta? Start here and where do I go? All the way around. Can I do trig on an angle that big? Where's the reference angle? Right there. From the nearest x-axis. Everybody cool? Okay. And fourth quadrant. All the way around. And where's the reference angle? Ooh, it's Pac-Man. There's the reference angle. Yeah, oh, of course. Or a hungry alligator. Right? Let's not... Holy crap. Oh, I have a funny story. No. You guys aren't going to believe this. Is the alligator eating the number? Oh, yeah.
Wait, is it recording? You're thinking.
Okay. So now I would like for you people to draw each and identify the reference angle. Now, when I say identify the reference angle, we've already identified it here, but this time I want a value for the reference angle. Now, I haven't shown you how to do this because I think you can figure it out. Go.
This one would be this one. Just use simple mathematics. Shut up. 9. What's 90 plus 9? Subtract. Where do you get that? Has to be close to Z. This should be 180. Okay, not 180. This is my thought, right? Alright, your thoughts are wrong. No offense.
So when I turn the screen back on, I'm going to have the thetas drawn and the reference angles identified, but I don't have values yet. Okay? So I'm going to turn the screen back on right now because it shouldn't have taken too long to draw the angles. It will take a bit of time to find the references because some of you take a little longer to add and subtract than others. Less than. Now the first one I did give the value because in the first quadrant, the reference angle and the angle are the same. Right? Okay. So, everybody should have been able to make this the reference angle because it's exactly the same as up here, yes? Now I want the value. So, if that is 120, what's the reference angle? 60. Why?
Because you either have 0 or 180.
Because, exactly. If I went all the way to there, it's half a circle, which is 180. But I'm 60 degrees back from 180. Everybody cool? So, if you're in quadrant 2, right? It's 180 minus theta. Everybody cool? All right. What's the reference angle in quadrant 3? This is 250. All the way to there is 180. I had to go past that, so it's 70, right? So in this one, how would you write your little shortcut for it? This one we said it's 180 minus theta, so what's this one?
250 minus, or whatever the value of the angle is, minus 180.
So it's this one in quadrant 3, it's theta minus 180. Right? Everybody cool? Because theta was 250, and then I got to go back to 180. I went 70 degrees past. Cool? All right, what's this guy? I knew somebody was going to do that. What's this guy's reference angle? I drew it badly. What is it? It is 10. I had to leave this much space because I wanted you to be able to see it. Right? Because all the way around would be what? 360, but I came back. So, how do we do that one? In quadrant 4, 360 minus theta. Everybody cool? Everybody cool? All right. Now, as always, this is the concept from today. Right? But now I'm going to give you the bridge to the next thing we are doing. All right? So, I just remind you, we already know that this is the coordinate grid made up of x's and y's, yes? Okay. So where would 3, 2 be? Quadrant 1, out there, yeah? So that is on the terminal arm, which means I start there and I go through 3, 2. Everybody cool? Do that. For all of them. We're going to talk about E, F, G, and H in a minute. What should you notice about the reference angles in E through H? What must they all be? The reference angles all have to be less than 90, yes. But what do you know about red R, black R, blue R, and green R? They are all going to be something. What? Yes, they're all going to be a number because they're obviously an angle. Hayden, well done. What would be special about that number? They're the same. Why? Because all these distances, 4, 2, 4, 2, 4, 2, 4, 2. And you will notice the opposite adjacent, opposite adjacent, opposite adjacent, opposite adjacent are all what? The same. So they must be the same angle. Except some of them are going to be Some of them are going to be actually, I shouldn't have said that. Ignore the last sentence I just said. They are all going to be the same, right? That's where I want you to stop thinking today. No, that's tomorrow's lesson. Everybody cool? They're all going to be the same. That's what you take away from today. All right? Your homework, well, not homework because you have 30 minutes and you've only got to do like 7 things. Do not do number 8. That should not be on there. I will paint over it with my whiteout. Do not do number 8. You are to do 1 through 7 right now. Meanwhile, I will be coming around and getting your rational expressions review score, which was, for those of you that have been scoring at home, was pages 182 to 184. I can't remember what it's out of. I think 39 maybe? Something like that. I'll be coming around and getting that score from you.